Have you ever wondered why the United States, known for its innovation and technology, lags behind other countries in high-speed rail development? Seriously, we're talking about a country that put a man on the moon, but when it comes to high-speed rail, it's stuck in the slow lane. So, what's holding the US back? Join me on this enlightening journey as we uncover the reasons behind this intriguing enigma. High-speed rail is a type of rail transport network utilizing trains that run significantly faster than those of traditional rail, using an integrated system of specialized rolling stock and dedicated tracks. While there is no single standard that applies worldwide, lines built to handle speeds above 250 kilometers an hour or upgraded lines in excess of 200 kilometers per hour are widely considered to be high-speed. High-speed rail first appeared in Japan with the construction of the Shinkansen between Tokyo and Osaka in 1964. Built on a wider gauge than Japan's existing narrow-gauge railways and without road crossings, sharp curves, or steep gradients, the Shinkansen could achieve speeds of 220 kilometers per hour. This reduced the travel time between Tokyo and Osaka by more than 50%, from 6 hours and 50 minutes to 3 hours and 10 minutes. Following Japan's achievement, the US tried to build high-speed trains of its own. These efforts were spearheaded by Claiborne Pell, a Rhode Island senator known for his unusual beliefs and behaviors. An early urbanist, Pell believed that high-speed trains were necessary to build the city of the future, and he drafted the 1965 High-Speed Ground Transportation Act and pushed it through Congress. The act authorized $877 million to create an Office of High-Speed Ground Transportation. A year after its creation, the office under the newly created Department of Transportation signed a contract with the Pennsylvania Railroad to create a high-speed passenger rail route between New York and Washington, D.C. By using trains capable of going 160 miles per hour, the planners hoped to reduce the travel time to less than 2 hours. This route would be followed by high-speed routes from New York to Boston and Philadelphia to Pittsburgh, and would ultimately be known as Metroliner. The Metroliner represented an attempt by the Americans to build their own bullet trains without incurring bullet train costs. Unlike the Shinkansen, the Metroliner required no new infrastructure construction, running on the same track as existing passenger service, though the rails themselves were upgraded. This allowed development to take place comparatively quickly, in just 4 years. But speeding up the project by avoiding infrastructure construction came at a price. Running over track designed for both passenger and freight required frequent, expensive track repairs, and the route was simply not suitable for sustainable high-speed running without major surgery. Because of the track's unsuitability, even after upgrades, Metroliner never achieved its design speeds of 160 miles per hour, instead topping out at 120 miles per hour, which is 190 slower than the Shinkansen. The rapid development period also meant that the cars were extremely buggy, and at any given time, 50% of the Metroliner cars would be out of service for maintenance. The ride was known for being extremely rough. Shortly after the Metroliner, turbo trains began to service the New York to Boston route. These trains, designed by the United Aircraft Company, were gas turbine powered. Though the trains had achieved speeds of 270 kilometers per hour, 170 miles per hour in testing, in-service track limitations capped their top speed at 100 miles per hour, and their average speed along the route was only 67 miles per hour. The turbo train proved to have even more bugs and ride issues than Metroliner, and turbo train service was discontinued in 1976. Thereafter, M497 Black Beetle, an experimental project by the New York Central, mounted 2 jet engines intended for use on the B-36 bomber to a normal diesel rail car. Though it achieved a speed of 295 kilometers per hour in testing and was constructed relatively cheaply, it was not considered viable commercially. Since the introduction of the automobile, passenger rail traffic had been steadily declining. From 1950 to 1970, passenger rail travel declined roughly, which is kind of a shame because there are benefits. Implementing high-speed rail will provide Americans with more transportation choices. It will also ensure that America remains an economic engine and meets the environmental and energy challenges of this century. Building high-speed rail will create hundreds of thousands of jobs. Every $1 billion in investment creates 24,000 jobs. These are highly skilled jobs that will revitalize the domestic rail industry, supplying transportation products and services. Many additional jobs are created through the commerce fostered through the economic activity and development which they spark. Upgrading passenger operations on newly revitalized tracks, bridges, and rights-of-way is spurring business productivity along corridors. The rail services will connect America's economically vital megaregions and help keep them mobile, productive, efficient, and internationally competitive. Implementing high-speed rail will keep billions of dollars in the U.S. economy by decreasing the amount of oil that the U.S. consumes. According to the International Association of Railways, high-speed rail is 8 times more energy efficient than airplanes and 4 times more efficient than automobile use. It will also decrease greenhouse gas emissions and improve air quality. Congestion on U.S. roads costs $140 billion in lost time and productivity. The U.S. population is projected to grow by another 100 million people in the next 40 years. The population growth is creating mega-regions that will not prosper unless they can be freed from the stranglehold of highway and airport congestion. The United States cannot build enough highway capacity or airport runways to meet demand. High-speed rail can deliver people from one downtown to another as fast or faster than air travel. The addition of HSR as an integrated part of America's transportation system will help airports work better and highways work better. It will also expand options for citizens in rural and small urban communities with increased transfer points and feeder services that connect with new HSR corridors. All this not to say that there are no problems. High-speed rail is generally regarded as the pinnacle of attractive and green transportation, but all too often it makes train travel more expensive and less flexible. In the end, costly high-speed lines may just push more people into cars. The main disadvantage of high-speed trains, other than their slow speeds, is that they require a huge amount of infrastructure that must be built and maintained to extremely precise standards. Since the United States is struggling to maintain the infrastructure it already has, particularly its urban rail transit systems and Amtrak's Northeast Corridor, which together have more than $200 billion in maintenance backlogs, it makes no sense to build more infrastructure than the nation can afford to maintain. It takes a lot more energy to move a train at 220 miles per hour than to move one at conventional speeds of 60 to 80 miles per hour. The power required increases with the cube of the train speed. The East Japan Railway Company, which operates both high-speed and conventional trains in Japan, says that moving a high-speed train car at 1 kilometer requires 50% more energy than a conventional train car. The California legislature created a high-speed rail commission to study the possibility of a rail line in 1994. Construction didn't begin until 2015. The authority projected it would be able to begin operating high-speed trains from Los Angeles to San Francisco by 2028. However, because of cost of overruns and the pandemic, the authority projects completion no earlier than 2033, nearly 40 years after planning began. As of 2024, the California High-Speed Rail Authority is working on the California High-Speed Rail project, and construction is underway on sections traversing the Central Valley. The Central Valley section, between Merced and Bakersfield, is planning to begin passenger service as soon as 2030. Brightline West is a privately operated route that is currently under construction between the Las Vegas Valley and Rancho Cucamonga in the greater Los Angeles area, with service set to begin as soon as 2028. Both projects received funding following the awarding of a federal grant of about $3 billion for each. So, there you have it, explorers! If you enjoyed this video, be sure to give it a thumbs up and subscribe for more content on United States updates. Until next time, stay curious and keep exploring the world around you. See you in the next one!